Yeah, all right, it's working. Okay, so success. As I was walking around and y'all were doing this, I noticed it is a warm-up, and I didn't really give you any instructions, but I noticed that a lot of people were doing like their presentation was lacking. I'll just leave it at that, okay? And one of the things that we're going to be emphasizing, as you read in the letter, is communication of your results, right? So unfortunately, in previous classes, the process of how you got to your product, your final answer, wasn't really stressed or emphasized as meaningful. But math is a language, and it needs to be communicated correctly. So I will be focusing on the process, namely your syntax and your notation of how you present your work. So as I teach you a problem every day up here, pay attention to how I'm doing it, because that's kind of how I'm expecting you to present it as you give it back to me on assessments and stuff like that, okay? So I'll show you what I mean. So this is a pretty good way to give you a problem. I've defined two variables, A and B, and they look like there's some handsome fractions. And I'm asking you to find and simplify the following. So to point out your question, yeah, if I ever use lowercase letters, that means that it's a part that you have to complete when you get your test, or if you've looked at the worksheets, multiple choice answer choices will be in capital letters, all right? So that means pick one, right? So if you did this warm-up, you can't just say B is the answer, right? Okay. So we're going to set up and evaluate the expression A plus B. So first of all, there's a difference between a mathematical expression and a mathematical equation. Anyone want to venture a guess as to the difference betwixt the two? Yes. The equation has an equal sign. Absolutely, yeah. Does this have an equal sign? No, so it's not an equation. It's a mathematical expression, okay? An equation equates to expressions. So we simplify and evaluate expressions, all right? So the first thing we're going to do with A plus B is we're going to substitute in the values for A and B. So beneath A plus B, not to the right side, we put 2/3 plus 5/4. That's the substitution step. Okay, so notice I work straight down. You want to get in the habit of working vertically. If you're in the habit of working left to right, you want to break that habit, okay? Some people last period were working left to right, and they were putting arrows as they went from left to right. That's really wrong, because an arrow is the wrong symbol to use there. If anything, you put an equal sign, okay? But you don't want to work left to right. You want to work vertically. And if you work vertically with an expression, you don't even need an equal sign, because it is implied that every step that follows above and below are all equivalent to each other, okay? They're all equivalent to each other. Okay, so now we're looking at 2/3 over 5/4. And notice how I've written those fractions. There's another thing to point out. I've used the horizontal division bar instead of the diagonal division bar. You want to get in the habit of using the horizontal division bar, because if you use the diagonal, you can make a careless mistake. If your denominator ever has more than one element in it, whether it's a factor or a term, the slanted bar needs parentheses, okay? Whereas the horizontals do not. So break that habit, break the habit of working horizontally, work straight down. Okay, with all that being said, now we're adding two fractions. What do we need to combine two fractions by adding them? A common denominator, okay? So we look at the denominators. I spy a 3 and a 4. They're pretty close, but they're not the same, all right? So the way that you learned in little school to get a common denominator is to do something to the expression without changing its value, right? They have to be equivalent. So what can we do to expressions without changing their value? We can combine like terms. We can divide out common factors or multiply like factors. We can add clever forms of zero, right? What's anything plus 0? Not 0. Same thing, right? Anything plus 0 is itself. We can also multiply by clever forms of what number? 1. Because anything times 1 is itself. It's the identity element of multiplication. So that's how y'all learn to get the common denominator. So if you look at your denominators, we want a common denominator. And ideally, we always want to be effective first. That means get the right answer. But we also want to be efficient. So ideally, we want a common denominator that is as what as possible? Small as possible. And we call that the LCD, the least common denominator, or in general, the LCM, the least common multiple, hungry. The least common multiple. So what is now the least common multiple of 3 and 4? 12. Very good, okay? 3 and 4 have no other common factors other than 1. In that case, we call those two factors this, co-prime. Two factors, and that's a term you need, two factors are considered co-prime if their only common factor is 1 or -1, okay? And what's cool about that then is anytime you have two factors that are co-prime, their LCM is going to be their what? Y'all told me 12. How'd you get 12 from 3 and 4? You multiplied them together, and the result of multiplication is called not a factor, not a sum, a product. Good, a product. There you go. We're terminology here, right? So the LCM of two co-prime factors is their product. Okay, so what you did then, and here's how you did it in little school. You multiplied by clever forms of 1. So I'll go ahead and set that up here, set that up here. And you said, okay, if I need to get a 12 and I have a 3, that needs to be a 4. So if I multiply by 4 in the bottom, I've got to multiply by 4 in the top. What is 4 divided by 4? 1. And what's 1 times 2/3? 2/3. So I haven't changed it at all. If you're doing your work and you get real lazy and you just put like a 4 in the bottom, and I saw some people doing that, and again, you didn't know I was going to be so much caring, but I am. If you just put like a 4 down there and you put like a times 3 down there, if you did that, is that true? Is that expression now equal to what you started with? No. So the details matter. So make sure that you're not cutting corners on something that you're going to be turning into me where I want to see your process. So 4 over 4 and 3 over 3, okay, like that. I multiplied by 1 twice. Okay, now from there, it all goes over 12. You could put it all over your common denominator. And then, of course, you multiply, so you get 4 times 2 is 8, 5 times 3 is 15. And again, there is the horizontal division bar. I'm working straight down. I didn't put an equal sign. 8 plus 15 is 23/12. Good. And we're working without a calculator right now, so 23/12 is considered a perfect answer. Can we simplify it? Do 23 and 12 have any factors other than 1 or -1 in common? No. So 12 and 23 are what? They're co-prime. And so we're done with this, okay? And working without a calculator, we don't want to give a decimal answer, really. Decimal answers are kind of more for calculator thinking. We want to give simplified fractional answers. This one is improper. What makes that improper? Bigger number on top. And we're fine with that. We're not going to write them as mixed numbers. That's kind of like in little school, you learned to do that when you were learning about wholes and parts and long division. Right now, we just like it as 23/12. But we know in our mind that it's about what integer? It's about 2, right? A little what than 2? Bigger or smaller? Just a little smaller. Just a smidgen smaller than 2. Okay, that's good enough. So 23/12 is a perfect answer. Now, that's one way to do it. And that's how you learn to do it in little school. We're going to be doing exponents tomorrow, and we're going to be adding and subtracting exponents that are fractional. And so you don't want to have to go off to the side and do all of this when it's part of a bigger and better problem. So we're not going to do it like that. You need to be able to do that in your head. So let's come down here and look at method number 2, which I saw some of y'all doing. 2/3 plus 5/4. Whenever you need a common denominator and your two denominators are co-prime, you could do what I call, for lack of a better term, the crisscross applesauce method or the multiply butterfly multiply method. I don't know. The name's not important. But you start in the top left. You got to start in the top left. You got to start in the top left. And you multiply it by the bottom right. 2 times 4 is 8. Then you take the middle sign, which is plus, and then you start on the top right and multiply down the other diagonal. 5 times 3 is 15. And then it's all over the product of the two. 3 times 4 is 12. And I saw some of y'all doing that little grouping symbol, like search a word type stuff. Yeah. Okay. So you have to start in the top left. And of course, then what's 8 plus 15? 23/12. Okay. So that simplifies it a little bit. You don't have to show me that you're multiplying by clever forms of 1. But let me put this in a cloud or a thought bubble. How about that? A thought bubble. Do you think you could do that in your head, in the thought bubble? Sure you could, right? You could just look at this and say, okay, those are co-prime, so 2 times 3, that's 4, times 2, that's 8. I'm going to hold that in my head, 8, plus 5 times 3 is 15. What's 8 plus 15? 23, and then all over 3 times 4 is 12. So you could go straight from here to here. And that's where I want you to strive to be, okay? So if you've been doing it on paper, that's great. Try to do that in your head. That's kind of bringing you to the next level, the pre-AP pre-cal level. All right? Let's try that. Let's give you another example, bonus example. We'll call this one example A2. How about that? Let me just give you two other random ones. How about a 4/7 plus 3 fifths? Yeah, that'll work. 4/7 plus 3/5. Try and just write down the answer using that butterfly, whatever I call it. And your answer would go, what, to the right of it or below it? Below it, yeah, ideally below it. If you do put it to the right with an equal sign, it's not bad, but it's not preferred. All right, so I'm going to go ahead one more time here and show that thought bubble. Put the thought bubble first this time. There it is. So 4 times 5, that is 20, plus 3 times 7, that's 21. All over 7 times 5, that's 35. So that gives you 41/35. Yeah. All right, and that's your answer. So again, you could look at that and go straight to there. 7 and 5 were co-prime, right? So this method works great. Now let's do example A3, all right? What if you have like 2/5 plus 7/10? Go ahead and do that one however you'd like. 2/5 plus 7/10. 2/5 plus 7/10. Simplify. Below it. Simplify. Huh? What? I don't know. Go ahead. You can do it however you want. You can do it however you want. You can use the new method that I showed you. You can do the little school method. All right, I'm going to skip the thought bubble this time. All right, starting the top left, 2 times 10 is 20. I can hold that in my head, 20. Plus 7 times 5 is 35. 35 plus 20, that's 55. And then the multiple of the product at the bottom, 5 times 10 is 50. All right, so that is one version of the answer. But what can we do with that? We could simplify. 55 and 50 are not co-prime. They have a common factor other than 1, namely 5. All right. So you don't have to show me that you're factoring out the 5. You can actually just divide it out of the top and bottom. 55 divided by 5 is 11. 50 divided by 5 is 10. So it goes below it. There you go. It goes below it. Notice there's 3 lines. I work straight down. No equal signs. Equal to, equal to, equal to. They're all equal to each other. It's an expression, okay? So the crisscross applesauce, or whatever you want to call it, method works great here, but we had one last step to do at the end, which is fine. And why was that? What do we know about 5 and 10 in the very beginning? Were they co-prime? No, they weren't co-prime. What was their least common multiple? Not their product, but no, 5 was their greatest common factor. Their least common multiple is 10. Yeah. 5 goes into 10, 10 goes into 10. Yeah. Okay? So the better way to do this, so that you don't have that secondary step of simplifying, is to always look before you leap, right? If you're going to jump into a swimming pool, just check to see if the swimming pool has water in it first, right? Good, yeah. So what you would do in this case, when we start working with exponents, you're just like, ooh, 5 and 10, those are not co-prime. The LCM is 10. And in your head, all you have to do to make the 5 into a 10 is multiply by 2. So in your head, you know you're just multiplying that by 2 over 2, which gives you a common denominator of 10. And then what's 2 times 2? 4 plus 7's already good. This is your thought bubble. You don't have to write it down. You're basically saying, okay, 5 times 2 is 10. So 2 times 2 is 4. 4 plus 7, what's 4 plus 7? 11 over 10. Yeah. And you're going straight from here to here. Okay? And you don't have that simplifying step in between. So the crisscross applesauce, when in doubt, you could do it. It'll work, but you might have some work on the back end. You always want to size up your problem first. What's the quickest, fastest, most efficient way to do a problem? Okay? Effective means be right. Efficiently means do it in as few steps as possible. The benefit of that is if you have fewer steps, you are less likely to have careless mistakes, or as some students call them, stupid mistakes. I like to call them careless mistakes. Those are the ones that are hardest to avoid, right? Because we're focusing on the big picture, and we're kind of just going through the mechanics, and we make careless mistakes. So if you have fewer steps, you have the possibility of mistakes diminishing. But the nice real benefit of it is if you're more efficient, you are saving what? Time, right? Time which can then be spent doing more what? Math problems. Yeah. Win-win right there. Okay? Win-win. Good. Okay, so that takes care of example A. Let's do example B. You've had a chance to do it. A minus B, so I'm just going to let that be the statement of the problem. And then underneath there, 2/3 minus 5/4. All right, so if we do our little crisscross applesauce method here, I'll show the thought bubble step. Where do we start? Top left or top right? Top left. So 2 times 4 is 8. Middle sign is now minus, and then 5 times 3 is 15. All over the product, 12. So that's what you could be thinking in your head. What is 8 minus 15? -7. Yeah. I put little lines through my 7 if you haven't figured that out. All right. Now, if you arbitrarily start in the top right, you would get 15 minus 8, which would give you what answer? 7/12, which is R-O-N-G? Wrong. Yeah, that's wrong. In fact, it is the exact opposite of the right answer. You couldn't be more wronger, right? So be careful. You have to start in the top left. By the way, 3 and 4 in the original problem were co-prime, so this works greatly. All right, so now a comment on this one. The answer is -7/12, which you could do in your head. What is actually negative in that fraction? The numerator? The way it's written, it looks like the numerator. But the whole thing is actually negative, yeah. So -7/12 is equivalent to, we can put equal signs, or I like the word or, it's equivalent to 7 over -12. Those are actually the exact same thing. Or, as it's typically written when it's typed out, the negative goes, yeah, in the middle, on the same horizontal level as the division bar, 7 over 12. So any of those are fine. I typically like to write it in the top or the bottom because later on, when your numerator and denominator have multiple terms in it, and that negative sign drifts up or down a little bit, it can mistakenly be associated with the top or bottom without being distributed. And now, again, it's wrong. So be careful of the details. But any of those would be correct. All right? All right, so good so far, so good? Questions, comments, concerns, quips, quotes? Good, clean jokes? Okay, so the next one. See, I'm going to come over here where I have some room. So ab, right? In a math context, what are we doing with A and B? What operation? Multiply, right? It's implied that they're being multiplied. Sometimes there is a little dot in between there to emphasize the multiplication, but you know that if you have two variables written side by side with no symbol, it's implied multiplication. It works as well if you have like a number and a letter, like 4B would also imply 4 times B. Same thing if you have 4, 5, right? That implies 4 times 5, right? No, that implies 45, right? So it doesn't work with two numbers side by side, but it works with two variables side by side, and it works with a number, a single number, and any combination of variables, okay? So yeah, 45 is 45. These are not the same. Yeah. Okay, so let's go ahead and plug in. A times B, that's 2/3. So right underneath there, 2/3 and 5/4. Can I leave it like that? No, because I just said those are two numbers. So here you could put a dot, which is fine. You'll see me use these guys all the time. These are not quotation marks. They are what? Parentheses, right. And I'll say that parentheses in a math class are your best friends. It's better to have them and not need them than to need them and not have them. Yeah. Okay, so how do we multiply fractions? Do we need a common denominator? No, we don't. We just multiply straight across, don't we? 2 times 5 is 10. 3 times 4 is 12. Brooks and done, right? Yeah, it needs to be simplified. So we're not done. 12 and 10 are not co-prime. 10 and 12 are not co-prime. We must divide out their greatest common factor, which is 2. So 10 divided by 2 is 5. 12 divided by 2 is 6. So 5/6 is the preferred answer, okay? Now, can we refine this process anymore? The answer is, of course we can, all right? We're not working with calculators right now. So if you notice what we did, we multiplied straight across first, and then we divided out the common factor of 2. So in general, when you multiply two numbers that are bigger than 1, you make the number bigger, right? And when you divide out something that's bigger than 1, you make the number smaller. As a general strategy, if you are working without a calculator, what strategy makes more sense? Make something bigger first and then make it smaller, or make it smaller first and then make it bigger? Bigger than smaller? Well, let's think of on the next rung of operations. Let's talk about like taking the square root versus the squaring something. If I ask you to take 81 and in any order cube it and then take the square root of it, if you try to cube 81 first, what are you going to be doing without a calculator? 81 cubed? Huge number, and you're like, oh my gosh, and you're having to do that off to the side, and then you're like, what's the square root of that, right? But if you go square root first, you got 9, and then you cube 9, and that's a much easier problem. So without a calculator, it's better to go what first? Small, and then go big. Now, I know when you learn this in little school, your teacher did not bring that to your attention necessarily as a strategy, right? I sat down with my daughter. She's been through little school, and she had problems like this. And I'm like, honey, have you thought about, no. She'd say, a couple more no's. The teacher wants us to multiply straight across first and then divide out. And I'm like, yeah, because that's something that everybody can do, and it gets them to the right answer. But you can, no. She said, I want to make my teacher happy. And I'm like, I get that, okay? That's a pretty good thing. Make the people you're working for under happy. But you will not make me happy if you don't think, okay, or care. So let's think about a better way to do this. Let's come over here. I'm just going to restate the problem. A times B, 2/3, 5/4. If multiplication makes it bigger and division makes it smaller, and we're supposed to go small before we go big, we should look to do what before we multiply? Divide. So we actually have 4 factors here. 2 and 5 are multiplied, 3 and 4 are divided, and because it's one term, we could do those in any order. So can we do any division first? The 2 and the 4, right? 2 divided by 2 is 1. 4 divided by 2 is 2. Can we do anything else? No. So notice what I did there. That's how you would show it. You're replacing those numbers with other numbers. We just divided out of 2. And even though they're not stacked vertically, we could do it because they're multiplied. They're still factors. And once we've exhausted all the division pieces, now we can multiply straight across. 1 times 5 is 5. 3 times 2 is 6. So we're going to be working with bigger numbers. We're going to be working with variable expressions, not just numbers. We're just kind of looking at easy numbers to start with. Look to go small before you go big. Divide before multiply. Subtract before add. Square root before squaring. Stuff like that, okay? All right, and then the last one, D, A divided by B. Okay, I'll put it right here, D. It's A divided by B, so if we plug in, we get 2/3 divided by 5/4. Okay, so notice again, I'm using the horizontal division bars. The bar in the middle is actually bigger than the other two because it's defining the numerator and the denominator. But we also have numerators in the numerator and numerators in the denominator. And denominators in the numerator and denominators in the denominator. In fact, we have a fraction within a fraction, don't we? What do we call a fraction within a fraction? We can describe it as a fraction within a fraction, but it has a name. Not hard, fun maybe. Compound or complex what? Fraction. Y'all have heard that word, right? It's either a compound fraction or a complex fraction. I will call it a complex fraction simply because compound fraction sounds like compound fracture. Ouch. When I was a freshman, I was skateboarding on a half pipe in the rain, and when I came in from a backside error, the board slipped out, my left arm, boom, hit the coping, and I heard a shotgun go off, and I was like, who's shooting at me? And I looked down at my left arm, and my radius and ulna were sticking out of my skin, and blood was squirting everywhere. And so I grabbed my hand, and my buddy's dad drove me to the hospital, and my parents were out of town at a wedding. And it took them 4 hours to get a hold of my uncle in Marion, who finally said, Yeah, give them some painkillers. So anyway, I have a bad experience with compound fractions and a little PTSD. So I will never call them compound fractions, okay? So complex fractions works for me, but I shared that story with you, so whatever. Truth, not a lie. Okay, so now that you have a complex fraction, a fraction within a fraction, you all have learned how to eradicate these, how to simplify them. What do we do? Flip the second one and multiply them, right? Yeah. Students come in with something kind of cute all the time. They usually say, my teacher said to stay, change, flip. What? Stay, change, flip. Okay. Stay, change, flip. Sounds like a cool dog trick, right? Stay, change, flip. Right? Good boy. Kind of imagine what the dog would do when you tell it to change. Like it switches outfits or it becomes a cat, but that's why it's a cool trick. Stay, change, flip. Good boy. Okay. So stay means at the top one, 2/3 stays. So 2/3 stays. Change. This right here means divide. In fact, that's where the division symbol comes from. The virgule, the division symbol. It's something divided by something. So we change division to multiplication, and then we flip 5/4 to become 4/5. All right? Let me slide this under here. Okay, perfect. All right, so now we turned it into like a problem like the previous one. And before we get all excited and just multiply straight across, we look first to do what? Divide. We look to divide, okay? 2, 3, 2, and 5, nothing common there. 4 and 5, 4 and a 3, nothing common there. But at least we considered it, right? At least we considered it. So nothing divides out. So we just multiply across and we get 8/15. Ta-done.
Could you not divide out the 2 and 4?
No, because they're multiplied now. They're both in the numerator, right? Yeah, if the 4 was in the bottom or the 2 is in the bottom, they have to be on opposite sides, remember, to divide them out. Yeah. Okay? So 8/15 is the answer. Now, that method still works, but you'll see starting tomorrow or the day after, our denominators are not always going to be so good looking, right? They might have more than one term in the denominator. And if you have more than one term in the denominator, stay, change, flip is very perilous, okay? So there is a better, more efficient method that handles complex fractions. Do you want to know what it is? Good, I'll tell you what it is. Notice I didn't wait for you to answer. Okay, here it is. Let's do it again. A divided by B, that becomes 2/3 divided by 5/4. All right, so we notice it's a complex fraction because we have fraction within a fraction. So what you want to do is locate what I call, kind of a cute term, your miniature denominators. Okay, so in the numerator, 2/3, its denominator is 3. So that's one of your miniature denominators. And in the denominator, we have 5/4, and its denominator, the miniature one, is 4. Okay, so you locate your miniature denominators. And then you ask yourself, what is the LCM of those two miniature denominators? And it's 12, right? So here is the method. You're going to multiply by a clever form of 1. Okay, so you're going to extend the main division bar all the way across. And you're going to multiply by a clever form of 1. That is the LCM over the LCM, okay? This becomes known as the Lickum over Lickum method. LCM over LCM. Lickum over Lickum. What's 12 divided by 12? 1. So we haven't changed anything. Now notice I kind of wrote them elevated because what we're really doing is we're multiplying by 12 over 1 times 12 over 1, okay? You don't have to show that, but I did that on purpose. Okay, so now at this point, you think of this as an upstairs apartment and a downstairs apartment, separated by the subfloor that is the main division bar. So cover up the downstairs apartment. The upstairs apartment is 2/3 times 12 over 1. Do we want to get excited and just multiply straight across and call it 24/3? You can, but what is 24/3 also known as? 8, okay? So here's what we want to do. Instead of multiplying first, we want to divide, which is going to be more important when we have variable expressions like quadratics and stuff. So what is 12 divided by 3? 4. And then what is 4 times 2? 8. So that becomes your new numerator. Divided by, and we do the same thing in the bottom, 12 divided by 4 is 3. 3 times 5 is 15. And you're done. When you multiply by the LCM over the LCM, your miniature denominators always become 1, which is trivial under multiplication, right? They always become 1 if you choose the LCM correctly. All right, so there it is. That's 8/15. Now, which one, the left column here or the right column here, required fewer lines of work? The right one, right? Correct? I mean, look at D, the left column. 1, 2, 3. It took four arduous lines. This one is 1, 2, 3. 3 is less than 4. Yeah. Okay. So again, the benefit of learning this process now with easy numbers is that when we start looking at like quadratics, okay, and a lot of variable terms, you'll have the process down. And that's when state change flip does not work. Okay? So we're reviewing, but we're learning new stuff, right? And we're also shaping strategies that previously we maybe haven't thought of, much less kind of incorporated into our work. We are in here until, what time? 42? Yeah, okay, so we're doing well. We're doing well. All right, any questions so far? It's good stuff, right? It's better than reading back to school syllabi. Okay. Or is it syllabuses? Syllabus? Okay. Let's go ahead and look at the other type of problem then that you'll have on your quiz tomorrow. You'll have something similar to this. I'll define A and B. Maybe I'll throw a C in there, and then I'll have you like do combinations of them, A, B, C, D, and you'll have to simplify. Okay? And I will probably grade your notation, but not deduct for it tomorrow. But I will certainly grade the answer. But over time, like on the next quiz, I will expect you to then have the correct syntax, the correct notation. All right? So come on board with that. All right, so the next thing that's very important to simplifying variable expressions, like when you have a quadratic or something, is how to factor. All right, so we're going to spend a lot of time reviewing factoring, but I'll start you off with one that's relatively easy. So how about this? X squared minus 8x plus 15. Is this an equation or an expression? It's an expression. There's no equal signs. How many terms does this have? 3. Yeah, terms are separated by plus signs and minus signs. Terms are separated by plus signs and minus signs. Factors are separated by multiplication and division signs. So this is an expression with 3 terms. This is a quadratic trinomial. Quadratic because it's x squared, trinomial because it has 3 terms. I want you to factor this trinomial into the product of 2 linear binomials. Degree 1, x to the first, binomial 2 terms. Okay? Go for it. This would be like one of the easiest type of factoring. Oh, I know why we have so much time, because we're supposed to have like 10 minutes for announcements, but I don't know if they're doing announcements yet. So, okay, cool. So this is probably the easiest type. I'll give you one first of all that factors. It's kind of frustrating if they don't factor. Because anyway, your leading coefficient, which is the number in front of your x squared term, in this case is a 1. So that makes it easy to work with. So here's how you do it. In general, the constant at the back is your target product, your TP, and the -8. The linear coefficient is your target sum. And so in general, you're looking for factors of your target product, 15, that add up to your target sum, -8. So what are some factors of positive 15 that add up to -8? -5 and -3. Okay? -5 times -3 is positive 15, and -5 plus -3 is -8. And because it's just x squared, that's just an x, and that's an x. So there's one of 2 possible answers, x minus 5, x minus 3, or flip them around, commute them, x minus 3, x minus 5, right? Piece of cake, piece of cake. Okay, let me give you one more here. Give me a chance to do this one here. How about 2x squared plus 8x minus 42. Go ahead and factor that one completely. I hope it works. This will be the last thing we do today. And again, once I get that new screen, everything on the front wall will be much better.
Good morning, unicorns. Please rise for the pledge.
All right, let's pledge, yeah.
I pledge allegiance
To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Honor the Texas flag. Pledge allegiance to the Texas, one state, under God, one and indivisible.
Please pause for a moment of silence. Thank you.
All right, if you want to keep trying it while he's talking, that's fine. I put a little hint up there for you if you're stuck.
Friendly reminders again about the 10-10 rule. Students, you are responsible for keeping track of that 10-10. Y'all been doing a great job. I think I see the hallway clear. I see about 95%. So just a couple of y'all, remember 10-10. You are not allowed to ask to go leave the classroom at the beginning or at the end, 10-10. And also, dress code, still doing a good job. Guys, no athletic shorts, please. When you get up in the morning, look at what you're wearing, no athletic shorts.
Also, students, if you brought money to pay for the iPad protection plan, staff are available in the commons during all lunches and after school. The last day to purchase is Thursday at midnight. You can also pay online with a credit card or a debit card. And also a big shout out to the JV and varsity volleyball teams. They both beat Reagan last night. Great job, girls.
Another announcement concerning parking permits. Those of students that are driving, make sure that you go online, the homepage, and register for your parking permit. The cost is $10. You can pick it up here in the office. It also includes two forms, one for the permit and one for the random drug testing, which is part of the criteria of parking on campus. You need to have that. Starting sometime next week, we'll not allow you in lot, and we're also going to start ticketing students and booting their cars if they don't have the proper documentation. So make sure you take care of that. This will be the cheapest permit you ever buy. So take care of it. Make sure you're parking correctly. Appreciate it.
Dana.
Oh, you need proof of insurance, but if you have a car, that's the law anyway. So make sure you have
Bring it with
license and proof of insurance. Thanks.
All right, true or false? The first rule of factoring is to look on your neighbor's paper. False, right? The first rule of factoring is actually to factor out the greatest common factor. Yeah, so this is a quadratic trinomial, but notice the leading coefficient is not 1. So it's not always going to be able to factor out, but you always want to check. So the greatest common factor, they don't all have a factor of x. So I can't factor an x out. But they all do have a common numeric factor of 2. So when you factor out the 2, since it's an expression, remember it has to be equivalent, you have to show that 2 that you're factoring or dividing out, essentially, in the front. And so now you divide all the numbers by 2 and you get x squared plus 4x minus 21. If that 2 is missing from the front, it's going to be incorrect. All right. Now you focus on what's left, and the 2 is still there. So now we can possibly factor this. This is now an x and an x. And let's see, a 4 and a 21, so that's going to be a 7 and a 3. But which one's positive? The 7, right? Because the plus 4 is positive, the larger number has to be positive, and that's going to be negative. So there's the factorization. So it ends up being an easy one with the leading coefficient being 1 once you factor out the common factor. If this had been like a 2x cubed and an 8x squared and a minus 42x, it would have been similarly just as easy, but you would have factored out a what first? Not just a 2, but a 2x, right? And then you would have this as your final answer. So real easy to adjust, okay? So on tomorrow's quiz, add, subtract, multiply, divide a fraction. And then I'll give you one quadratic to factor with a nice leading coefficient of 1. Kind of a nice way to start the quiz, all right? Have a good